Before the internet, before smartphones, before anyone had ever seen Earth from space, there was one question that kept engineers awake at night. Not, can we build a rocket, but can we build one that actually works? Because the history of American rocketry isn't just a story of triumph. It's a story of explosions, of failures, of billion-dollar mistakes, and of 8 machines that changed everything we thought was possible. These are every NASA rocket ever built and what happened to them. It didn't start with NASA. It didn't even start in America. The rocket that launched the entire space age was built by Nazi Germany in 1944, the V-2, the world's first long-range ballistic missile. It designed not to explore space, but to destroy cities. It carried a 1-ton warhead at 5 times the sound of sound. Over 3,000 of them were fired at London, Antwerp, and Paris during World War II. But here's the thing nobody talks about. The V-2 was the first human-made object to reach the edge of space. Every single rocket on this list, every engine, every guidance system, every staging mechanism, traces its DNA directly back to this machine. When the war ended, NASA didn't destroy that knowledge. They recruited it. Operation Paperclip brought over 1,500 German scientists to the United States, including the man who designed the V-2 himself, Wernher von Braun. The space age wasn't born in Houston or Cape Canaveral. It was born in a Nazi weapons factory in the Harz Mountains, and America built everything that came next on top of it. The Cold War is at its peak. The Soviet Union has just tested a hydrogen bomb. The pressure on American engineers is unlike anything they'd ever felt. Von Braun and his team had one job: take what they learned from the V-2 and make it better. The result was the Redstone, America's first operational ballistic missile. 21 meters tall, 1 engine, simple by today's standards. But the Redstone did something no American rocket had ever done before. It worked consistently. And in 1961, a modified version of this rocket carried Alan Shepard into space, making him the first American to leave Earth's atmosphere. Not on a cutting-edge machine, not on something designed for exploration, on a glorified missile with a capsule bolted to the top. The Redstone was never meant to reach the moon. It barely reached space, but it proved something critical. America could do this. And now they needed something much, much bigger. If the Redstone was America learning to walk, the Atlas was America trying to sprint before it knew how. The Atlas had a problem that no rocket before or since has ever had. Its fuel tanks were so thin, so impossibly thin, that the rocket could not support its own weight without being pressurized with nitrogen gas at all times. If you depressurized an Atlas on the launch pad, it would collapse under its own weight like a tin can. Engineers called it a balloon tank. The Soviets called it insane. But it worked most of the time. In its early years, the Atlas had a failure rate of over 25%. 1 in 4 rockets exploded. That's not a footnote. That's a catastrophe by any modern standard. And yet NASA pushed forward because the Atlas could do something no other American rocket could. It could reach orbit. In 1962, it carried John Glenn around the Earth 3 times, the first American to ever orbit the planet. The Atlas turned failure into legend, but everyone knew it was a stopgap, a stepping stone, because the Soviets were already pulling ahead, and America needed something that could win. There are machines that change history. And then is the Saturn V. 111 meters tall, the height of a 36-story building. At liftoff, it produced 34,000 kilonewtons of thrust, more than the combined power of 85 Hoover dams firing simultaneously. Nothing built before it, nothing built since, has ever come close. The Saturn V wasn't just an engineering achievement, it was a declaration. America looked at the Soviet Union, at Sputnik, at Gagarin, at every humiliation of the early space race, and said, "Watch this." 13 Saturn Vs were launched between 1967 and 1973. 13 out of 13 succeeded. Not a single failure, not a single crew lost during flight. In an era when rockets exploded routinely, the most powerful machine ever built by human hands had a perfect record. It carried 24 astronauts to the moon. 12 of them walked on its surface. And then, almost incomprehensibly, America stopped. The program was canceled. The production lines were shut down. The engineers retired or moved on. 3 Saturn Vs sat on their launch pads and were never flown. Today, they sit in museums, horizontal, motionless. The greatest rocket ever built, retired after 6 years. To this day, nobody has built anything like it. After the Saturn V, NASA made a promise, a reusable spacecraft, cheaper than anything before it, flying up to 50 times per year. The Space Shuttle was supposed to make space routine. It did not do that. The shuttle was the most complex flying machine ever built. 2.5 million parts, 230 miles of wiring, thermal tiles so fragile a single missing one could destroy the vehicle on re-entry. And it was never cheap. Each launch cost over $1.5 billion when all costs were accounted for. Compare that to the Saturn V, adjusted for inflation, and the shuttle was actually more expensive per mission, to carry less payload, to go no further than low Earth orbit. But none of that is what the shuttle is remembered for. On January 28, 1986, 73 seconds after liftoff, Challenger broke apart over the Atlantic Ocean. 7 astronauts gone. The cause? An O-ring seal that engineers had warned about for years, that failed in cold weather, that management decided to ignore. 17 years later, Columbia disintegrated on re-entry. 7 more astronauts lost. Again, a known problem. Again, warnings that went unheeded. 135 missions, 30 years, 2 catastrophic failures. The shuttle flew its last mission in 2011. The promise of routine, affordable space access died with it. What came next was supposed to fix everything. It didn't. Most people have never heard of the Titan IV. That's not an accident. While the shuttle was flying astronauts into orbit, the U.S. Air Force was quietly operating the most powerful expendable rocket in the American arsenal. No crew, no fanfare, no live broadcasts. Just classified payloads launched into space without anyone knowing exactly what was on board. 62 meters tall, a failure rate under 5%, 39 launches over 15 years, each one costing $432 million. The Titan IV never made headlines because it wasn't supposed to. But the satellites it launched shaped the outcome of every American military operation, from the Gulf War to Afghanistan. It retired quietly in 2005, replaced by cheaper, more capable systems. The most important rocket most people have never heard of. By the mid-2000s, NASA and the U.S. military had a problem. The payloads were getting bigger, the budgets were getting tighter, and the Titan IV was gone. Enter the Delta IV Heavy. 3 rockets strapped together, 3 engines firing simultaneously at liftoff. On its very first launch in 2004, 2 of the 3 engines shut down prematurely due to cavitation in the fuel lines. The rocket still made it to orbit, barely. It was that kind of rocket. Never elegant, never cheap. At $350 million per launch, it was one of the most expensive expendable rockets ever operated, but relentless. The Delta IV Heavy carried some of America's most critical national security satellites, the Orion crew capsule on its first test flight, the Parker Solar Probe. It flew 16 times over 19 years, lost no payloads. Its final launch was in April 2024. The end of an era, the last of the old guard. Because by the time the Delta IV Heavy retired, something had already changed the entire industry. Something that made every rocket on this list look expensive. The Space Launch System was supposed to be NASA's return to greatness. A rocket as powerful as the Saturn V, built with modern technology, carrying astronauts back to the moon for the first time in 50 years. It first launched in November 2022, over a decade behind schedule. The development cost, $23 billion and counting. Each launch costs an estimated $4.1 billion. To put that in perspective, SpaceX launches its Falcon Heavy for around $150 million. The SLS costs 27 times more per flight. Critics called it the Senate Launch System, a jobs program disguised as a rocket, kept alive by congressional pressure from states with aerospace contracts. Supporters called it the only rocket capable of carrying NASA's Orion capsule and the hardware needed for the Artemis lunar program. Both things are true. The SLS is simultaneously the most capable rocket America has built since the Saturn V, and the most expensive, most controversial machine in NASA's history. It launched Artemis II in early 2026, carrying 4 astronauts around the moon for the first time in 1972. Whether that justifies the cost depends entirely on who you ask.